online FDP on sixth day, titled Demystifying Transformers, the Brains Behind Generative AI. So it's our deepest gratitude to welcome our speaker of the day, Mr. Bharath Natarajan. And I would like to request Anita ma'am to introduce Bharat sir.
Thank you, ma'am, for giving an intro talk. Let me talk about sir. Agila, ma'am. Okay. Okay. Bharat sir, actually, he was actually working on HCL. Now he is residing in United Kingdom, and he is a cloud and AI engineer who has more than 13 years of designing, building, and operating production scale machine learning and generative AI platforms, which turns the raw enterprises data into real-time insights and revenue generating projects. And also he has adapted full life cycle from rapid prototyping through domain driven architecture, secure cloud deployments such as AWS, Azure, GCP, and also he has a good knowledge about MLOP's automation system. So he was a very good engineer with various machine learning techniques, operation and automation system. He is expert coder in Python and Java, and he also has a fluent knowledge in data analysis and modern DevOps practices. And we welcome you, Bharat sir, for today's session to have it on conversational AI and chatbots. Over to you, sir. Thank you.
Sure, ma'am. Hello, everyone. Welcome to this session on conversational AI and chatbot. So we'll start in a moment. Before that, first of all, thank you all for joining this session. I'm quite excited to share my knowledge in this domain. So hope it'll be a useful session for you as well. So we are going to explore what's conversational AI, what are chatbots. So
Sorry, Bharat sir, can you please share your screen?
yeah, sure, ma'am. So uh, I'm sharing my screen. Hope everyone is able to see my screens.
Yes, sir. Yes.
Okay.
Slideshow moves.
Yeah. So hope everyone is able to see my screen and the presentation is visible. So if you face any difficulties, let me know. If not, we can get started. Yeah, so today to give a quick introduction about myself. I work as a specialist engineer, especially in data and AI. I'm part of Tech Catalyst. It's one of the big four consulting within all over the world, and they primarily started in UK. So that's my like about my organization, which I'm working on. With that, today, these are the topics which we are going to cover. So I will give a quick introduction about conversational AI. So what it is, what are the different application, and then we will see, like many people will think about when they think about conversational AI, they will also think about Gen AI. So we will quickly see what is the difference between both, where they differ. Although both are AI technologies, there are subsequent differences between these two. So we'll explore that. Next is we will see the architecture. So what a conversational AI architecture will look like. And then with that, we will go to so retrieval augmented generation. So there is a popular technique. For example, the LLMs, right, which powers the conversational AI, they are trained on massive amounts of data. So if they don't answer, if they don't know the answer, right, for whatever the question you're asking or whatever the conversation, it might hallucinate. So how we can reduce that hallucination using a RAG framework. So conversational AI with RAG. So how to use RAG with conversational AI. We are going to see that. So and also we'll quickly see about the RAG retrieval augmented generation. So where we use Gen AI models for generation, where we augment its response using retrieval from vector database like AI search. So those things we are going to see. And then finally, the exciting part, we are going to see about a live demo. So about application which we have built or conversation. It's an kind of a travel assistant and an insurance agent, so which will help you with your questions on that particular domain. So next is finally we'll spend some time on Q&A and then we'll close this call. So that's pretty much the quick agenda about this. With that, Yeah, so what is conversational AI? So conversational AI is a domain in artificial intelligence which can stimulate human conversation. Just like so Gen AI, if you see around 5 or 6 years back, right? So we didn't have Gen AI, so there were only ML. So but still there was AI, but it didn't pick up. It's because the human interaction, HCI, human computer interaction, has to be happen through programming language or any UI interface. The Gen AI has changed that, and then with that, conversational AI has also substantially changed. Earlier, we had to rely on like NLP models, so in order to do the conversational AI. So now the Gen AI has changed that, so which allows AI to understand. So since Gen AI is trained on NLP, natural language processing, and natural language understanding, this has enabled us to use Gen AI and the conversational AI. So for all the chatbots and generative and make use of its generative AI capabilities. So how it works, what will happen is, so the conversational AI systems, right? They get trained on a large amount of data. It might be text and speech. So how humans interact with each other. Like for example, there is a customer and there is a client. For example, if you're a banking client, right? So you might reach out to your bank for any support with your account. So in that case, right? So what they will do is they would have trained this conversational AI on all those banking transactions which they previously had, and then it learns the pattern. So how an human agent communicates with a client, how they address, it will learn, and also based on the instruction, right? Prompt engineering. So that's the part of conversational AI, which you train your conversational AI to uh, prime it to how to respond to different questions that a particular customer asks. So those things, right? So these things will help the conversational AI system to understand and process human language. So the system will use the knowledge to interact with the humans in a natural way. This knowledge can come from different sources. So the one thing is, if you have a proprietary data, you can convert it into text, and then you can convert it into vector embeddings, and then you can ingest that into AI search or vector database, and then you can use that as a knowledge. Or else for federated responses, right? So you can directly have a connector that helps you to connect to the appropriate sources. For example, if you wanted to do a web search, right, you can have a connector for web search. So where this conversational AI framework will like do a web search filter. For example, if you're asking about, let us say you're working on a conversational AI that has been deployed on as a travel agent, which is responsible for booking your flights or hotels. In that case, what it will do is soon after you ask, like, what are the flights that are available for, let us say, Mumbai or Delhi. So it'll do a web search. So what we will do is for that conversation AI, we'll provide certain tools, and then that it will use that tool to go and fetch all the flight details, and then within what is your budget, those things, right? Based on your budget, it can suggest appropriate or that is flexible for your budget and which is appropriate for your scenario. So those kind of things, right? You can do it using tools. So those are the knowledge which will provide knowledge bases. A knowledge base can be of multiple sources. So a conversation will automatically decide which knowledge or tool to use based on the interaction which is it's having with the client or customer. So and also it will improve the response quality over time. So what it will do is for every interaction you're doing, so it will keep listening to your feedback or how it communicates. It will fine tune as it goes. So there'll be provisions for and conversational AI. We'll going to see that in detail in the architecture diagram in a moment. So yeah, so conversational AI applications. Um, these are the different spheres of a conversational AI application. The first one is you can have a like what are the different types of conversational AI application. One thing is you can use conversational AI in Gen AI agents, where uh, these are virtual agent that uses Gen AI to power text or voice. These are all called Gen AI agent. So next one is these, you can see I told about RAG, right? Retrieval augmented generation. So that one also is a kind of a Gen AI agent, which you needed to train the using your context window of a Gen AI LLM model. You need to train that to answer those questions with your which are proprietary to your scenario. Next application where you'll use conversational AI is chatbots. These are the form. This is a famous application where you will see almost if you've interacted with any bank, for example, HDFC Bank, there is a chatbot called Eva. So you go and type your question, it answers almost these days, right? So every web application or any app, for example, Zomato or if you have Swiggy, so all this use chatbots. So the first today, by default, these are used in customer wherever there is a direct customer interaction, right? There, this chatbots have been deployed rapidly these days. So almost, I think, anyone who has used internet to order for if they've used any application to order food or if they have interacted with a bank for any support, they've come across chatbot. So your first point of reach is the chatbot. First, it will try to solve your problem using the knowledge base. And if it's not able to do that, then only it will transfer to a human agent. So as I told, chatbots will be used wherever the direct customer service is required and to answer questions and support. That's the second application. The third application is the popular most, like if you have any Android or iPhone, right? You have been using Siri, Google Assistant, or if you're using Amazon Echo devices, right? You would have used Alexa. So these are called virtual assistants. So for example, an iPhone, if you see Hey Siri, it'll come up and respond. And then if you ask about anything in your voice, so like it would respond. What will happen is there we are using conversational AI. Soon after you speak, right? So what will happen? That speech will be converted to text, and that text will be inferred by the LLM or the large language model or GenAI model, which is behind this virtual assistant, and then it will uh, respond to your question. So that text, right, whatever comes, it will be converted again back from text to speech. There are various services within the different AWS or Amazon or like Google Cloud, Azure, which does this. So these are called virtual assistants. And then one famous research that's happening in virtual assistant is on-device virtual assistants. For example, in Apple has been discussing this for quite a while. So what happens is they will deploy there is something called SLMs, small language model. It's not as robust as large language model because large language models requires lots of compute power to run, but the small language models, right, it can run on your mobile devices. What it will do is they will deploy this small language models onto your smartphone or your local computer or any, for example, if it is a IoT system, so if you're using a smart industry, so they can deploy this SLMs, which can work on low compute uh, power. So on these devices, which will, without using the internet, right, it will try to whatever information that's available locally. So it will try to answer your question using that. When it can't answer your question, then only it safely encrypts your data and it transfers to a remote model, which might be an LLM. So those are the scenarios where a lot of research is happening. So on using both SLM for your local devices and LLMs when SLM on your local device can't answer that question. So those are the things that come under virtual assistants. So next thing is text to speech. So yeah, so to create audiobooks, whenever you're reading a PDF, right, you want to hear it in a like a note or a voice instead of reading through all the pages. Of example, let us say you're using Google Map. If you switch it on, right, so the mic, it will, you can tell what you needed, or you can take me to a nearest coffee shop. You can tell like that to the Google Map so that it will take you to that. So those kind of scenarios, right? That's where you use text to speech or speech to text. So those kind of scenarios. So also text to speeches, for example, as I told in like customer support bots, right? For example, if you're calling a contact center, so we will see what is a contact center in a moment. So in those scenarios, right, if you interact, you call, those call audio calls, which you make phone calls, that will be transcribed and converted initially to from audio to text, and then the text will be processed by artificial intelligence, and then back once it gets, it will respond the text. That text needs to be again converted to text to speech, and then they will answer your phone call. All these things, right? This is a very complex process. It will happen in a split of a second, so you will not even like know it has happened. There was a chatbot or a conversation AI behind all this process. So that's the beauty of this solution. So for those scenarios, we use text to speech. And next is speech recognition software. That's another famous application of your conversational AI. So where, for example, let us say in this meeting, so let us say there is a Teams meeting, right? So there is a transcribe option in Teams meeting as well. I'm not sure if this Teams meeting has been enabled for that or not, but so you can transcribe so that whatever I speak, right? So it will automatically recognize my speech and it will convert that to text, and then it will take a quick notes about it. We use this technology like for transcribing lectures, transcribing our meetings. So for example, we can't remember everything what different people speak in the meeting. Later, if you wanted to review that, right? Earlier, we need to take manual notes. This transcribe feature is a lot of handy for us as a tech developers to quickly see what different people said, what are the old context, even that, right? Once we transcribe, we can take that transcribe. What we do is we take that all those transcribed meeting notes and feed it to LLM and ask that to summarize it, so that it will summarize in 4 or 5 points what was the gist of that particular meeting, what they discussed, what are the key actions that we need to take. Those things, instead of going through all the conversation, or instead of remembering and taking note everything, I can do that in a split second. So those are the scenarios. And next thing is phone calls, right? So whenever you make a phone call, so to a let us say a customer support service center. So first time they might like don't know who's calling. For the next time, right, it can using a voice, it can recognize, okay, this is the customer it calls. We had interacted with this customer earlier, so this was the feedback that was given, and then based on this feedback, now when I'm interacting again, I need to change the way I approach so that the customer has a good experience with me. So those kind of intelligence will happen through phone calls. And next is captions. So for example, you would have seen YouTube videos or any live captions, right? As we speak, if we enable captions, so it will tell it what the person is speaking about. So those are the scenarios, different scenarios where you'll use speech recognition software. Next thing is data capture and feedback. So as I told, as we interact with, right, so the conversational AI needed to capture the data, and then it needs to capture the feedbacks. These are the scenarios. For instance, for example, let us say you go to Amazon and you purchase an item. So after that, what you do is you give a feedback about that particular product which you purchased from Amazon, and then what this conversational AI chatbot will do is it will retrieve, for example, if similar customer is asking for a similar product, it will see what are the feedback that was given, and then it will tell that, okay, these many customers bought this, these are the pros and cons. We have seen in Amazon, right? So there is already a, like if you go to the reviews button, you will see there is a quick summary of what was the advantage or what was the good things about this product, what was the like what was disadvantage about this product. So those things, right, you can pretty much get it using this conversational AI for data capture and feedbacks. So that's pretty much what it is about different application of conversational AI, way we are using it. So it can be deployed in any of this application. There are many other applications, but whatever I listed here are the most important ones where will be using conversational AI. So with that, let's go to, yeah, the next interesting part is conversational AI and Gen AI. Many people will think like, okay, conversational AI, Gen AI, both are AI, both are similar. So what is the difference? So you might ask that question as you discuss. But the key difference is conversational AI will understand and manage dialogue. So conversational AI is specifically built and it's specialized in human conversations. So those are the system that understand how a particular, for example, let us say your human interacts with a human customer agent, right, support agent, how they interacted. So for example, if they say something, right, so there is like speech language, right? For example, we would have said something differently rather than when we're doing in writing. So those kind of nuances, right? So this conversational AI can understand how and two humans can talk together, how the dialogues between when a group of humans are speaking, or one or more humans, or two or more humans are speaking with each other, how this dialogues will evolve. So those kind of things it will understand. So that's the beauty of conversational AI. Whereas in generative AI, as the name suggests, generative, it generates new content. It can generate text, it can generate audio, it can generate video. So for text, like nowadays GPT-4o or GPT-5, those are multimodal, right? It can take either text or audio or video or picture as input, and then it can respond back in text, or can even generate images. Also, there are generative AI models that have been developed by Google. So which will so if you give it text, right, it can generate videos. So for example, with the, I think there was a recently in Google developer event, they demonstrated a model. If you give a single line of text, it can generate around 5 minutes of video for that, from that particular one single line of text. That's exciting. So lots of innovations happening. So those kind of things, those are called generative. It creates new content. It can be text or video or any. There are multimodal. So next is task and domain specific. Whereas conversational AI, it is developed for a particular task or domain specific. As I told earlier, for example, I can deploy conversational AI into banking service support. So that would have been trained on the banking interaction, how a customer agent working in a bank had interacted with that. So it would have been trained on that, so that it can work specifically. If you deploy that same conversational AI, for example, let us say uh, uh, to insurance domain, right? It will not perform well, and because it was trained on like banking domain, you need to retrain it on insurance domain conversation, so that it will understand the terms that are specific to insurance. For example, in insurance, you will see like policy claim and reinsurance, underwriting. So those kind of things, right? Those kind of terms, that domain specific terms, it will not know. You need to train that there. So that's why conversational AI or task or domain specific models. So they are predictable and scope bound. For example, they work on a, like, okay, so if this is the scenario, this is the response it will give, this is the knowledge base it will use. Those kind of predictable and conversational AI are predictable and also scope bound. So it'll operate in a particular scope. So and then where you will deploy conversational AI, it's best for Q&A or guidance or any customer support, wherever wherever you need these kind of scenarios, right? So that's where a conversational AI works at its optimal level. So next thing is when you come to generative AI, so first is it creates new agent, and then they are the logged foundational model. So if you remember GPT-4o or like the Gemini, Google Gemini models, or Amazon Q. These are the different generative AI models. So what powers is large foundational models? There are deep learning neural networks which will have n number of layers, millions of layers, which would have trained on massive amounts of data, almost all the internet data. So those are the, it would have trained on on the GPU or TPU kind of power, computing power, which is not affordable for individual person. It's only for affordable for enterprise or company. They wanted to develop their own LLM model. So like generative AI is that. So wherever it's used, the large foundational models. And then generative AI models, as I told earlier as well, they are very creative. So sometimes if they don't answer, so they hallucinate. Hallucination is nothing but it will make up an answer from whatever it learned. So too much knowledge is not good, right? So same way, like that's the reason. In order to, we will see how to eliminate this hallucination. That's why we will use retrieval augmented generation. So which will ground your generative AI models to proprietary data, so that it will only answer the questions related to your proprietary data, so that it will doesn't hallucinate. If you ask something outside that proprietary data, right, it will simply say, I don't know the answer. So that's what RAG frameworks helps to reduce hallucination. And next, for generative AI models are best for teaching materials and examples. Uh, those are the scenarios. If you wanted to deploy a raw generative AI model, so it can be used as a teaching material, or it can be used as an example. For example, ChatGPT is a generative AI model, so which is a raw generative AI model. It doesn't use any retrieval augmented generation until and unless you provide. So for example, you can upload a PDF file, and then it can answer, okay, I've given a PDF file. You use that as a context, and then based on that, you give me an answer. On that case, what it will do is it will restrict itself to the content within the PDF, and then based on that and its previous knowledges, so it will answer your question. So yeah, those are the major differences between what conversational AI is, what and what's generative AI is. So hope this clarifies you and like eases your dilemma about what is conversational AI and Gen AI. Next is like many AI systems, right? It will, so there are scenarios where you will use both conversation in a, it might be a conversational AI scenario. We can use generative AI as well. So whereas the conversational AI will be used to interrupt what the customer or a learner is trying to tell. With generative AI, what it'll do is over and above that. So once it understands your intent, right? So then you can use generative AI to produce context-rich responses. So this hybrid approach has been widely used across the industry, which has improved the way we interact. So that's the other approach. So this hybrid approach extends learning support beyond scripted Q&A towards more adaptive and personalized engagement. So that's pretty much. And like these are the conversational AI architecture. How will you like the flow of a conversational AI architecture? First, what it'll do is user comes and then they like say something or type something. If it is an audio, so for example, let us say you're using Siri. So you will speak to Siri. You say, "Hi Siri. So can you tell me the weather? What's the weather like today?" So what it will do is there is automatic speech recognition. So it will come into picture. What it will do is it will use that ACR. For example, if you have observed, right, so Siri will only respond to, for example, if there are 5 members in a family, so you are using the phone, you have recorded your voice in the settings, so it will respond only to your voice. It will not respond to your other family members' voice. It's because it's using this AS or automatic speech recognition. So it will recognize only your voice. It will not recognize, for example, your like a brother or sister or any family member, their voice it might not recognize because it specifically it is trained on automatic speech recognition. So it will respond to your voice only. Next is once the voice is recognized, then whatever you speak, right, that goes to the NLP model, natural language processing. So what it will do is like there are different natural language processes models which are trained on languages. For example, most of the natural language models are trained on English language. If you wanted to, nowadays there are lots of NLP models that are emerging, especially in India, right? So we have almost different languages, more than 18 plus languages. So there are a lot of research happening, especially in India, where they are developing an NLP, natural language processing model for our mother tongue. For example, in Hindi or in Tamil or Telugu. So those kind of models, right? So it's evolving. So in that case, right, for example, I read an interesting article recently where they have used NLP, which is trained on like for example, if you ask something in Marathi, right, so it'll respond. If you ask something in Marathi, it will what it will do is it will uses this NLP that has been trained on Marathi language, and then what it will do is it will go and then convert that, and then it will respond back in Marathi itself. So for example, if a customer asks in your any question in English, so to a person who's not knowing English, right? So they can quickly what they do is they feed that voice, customer voice, whatever they ask to this model. So what it'll do is it'll automatically convert that using NLP. It'll convert that from Marathi to uh, different language, and then it will tell them like in Marathi itself. Even though they asked in English, it can tell in Marathi what the customer wants, and then the person can give the response in Marathi, which will again convert back to like from Marathi to English, and then that will be played to the customer who's speaking in English so that they understand. So those kind of application, especially I saw it's happening in Swiggy, I think so. That's one of the application. It's happening, especially in the NLP domain. So next is dialogue management. So how a dialogue should happen between a customer, what are the how you address your customer, like how you interact, so those kind of things, right? So it'll happen in dialogue management. And natural language guidance, so how it needs to respond to a customer, that's will be taken care by this natural language guidance. And then once everything is done, it will be converted. Initially you asked your question in an speech or an audio, so it'll get converted into speech to text, and it will be processed by NLP, dialogue management, and then it will given back to the natural language guidance model. And then the back once that is done, everything will happen in text. Finally, the text was again converted into speech, and then that's given as an output, and then that's given back to your chatbot, a conversational AI chatbot, which can convert, as I told in the Swiggy scenario, it can convert back from text to speech, and then it will play that audio. So those are the like how a typical conversational AI flow will happen. So different KPIs in this scenario, right? This should happen in a split second. Although I explained this much process, right? So it should happen in a split second. So, for example, if customer asks a question and then if the conversational AI comes and answer after 3 or 4 minutes, that'll be a bad customer experience, right? It should happen in real time. So response time, KPI, key performance, and this is for conversational AI. One of the things which you needed to consider is response time. So it should happen almost in real time. So that's one thing. Next thing is accuracy. Whatever it's saying, it should be accurate. For example, if I ask, let us say in Swiggy scenario, I ordered a food. I wanted to order a food. Let us say I wanted to order a North Indian thali. So it should be able to quickly locate me the restaurants that serves that North Indian thali or a South Indian thali meal. So those are the accuracy scenarios, right? It shouldn't suggest that is a restaurant that is serving a Punjabi style food. So that'll be awkward experience for a customer. So those kind of accuracy is very important. Also in banking domain, also whenever you interact, so whatever information the chatbot gives, it should be accurate and dependable. So and it should be reliable as well. So those are the accuracy and engagement, right? So it should be, the conversation should be very live. For example, in many scenarios, I see that certain times the chatbot might not be lively. Like within one or two conversations, I can understand that this is not an human. I can easily figure out whether it's a chatbot or a human behind the interaction. So that will be a bad customer experience, right? So whatever the chatbot is, whenever it's engaging, it should be at its optimal level, and that it need to keep that engagement with the customer so that they don't feel the difference between the chatbot or a human agent. So you needed to one of the key performance indices for conversational AI measurement is the engagement, customer engagement. So that's pretty much about the flow of conversational AI, how it will happen. Like in conversational AI, this one is provided from like a source from Gartner. So research on conversational AI. So these are the things, different like parts of a conversational AI. So the first is user interface, where the users or customers interact with. Next is language processing. So like how it will process your language is called natural language processing. Whatever you tell, right, it need to convert that text, like speech, into text, and then it needs to process that text, it needs to understand. So those are called conversational. And then next is response generator. Based on that, it needs to generate a response. Next is intent handling. So whatever is your intent, right? So it should handle that. For example, if I'm asking for a weather, it should give me the weather, or whatever I'm intending to do, it should handle that. So that will be there in the content, like conversational AI. Next thing, these are the internal like parts, whereas the contextual awareness, as I told, we need to train the conversational AI on different scenarios. So that's another thing where you will use contextual awareness. For example, if the conversational AI has been deployed in banking domain, it should helpful with the banking queries. So it should know that conversational AI should know it's operating within the banking domain. That conversational awareness is very much important to make it more specialized and curated response. Next thing is exception handling and escalation. For example, there should be scenarios where, for example, let us say conversational AI can't handle something, so or the query was very complex for it to understand. So in that case, right, it should escalate, or it should transfer that to a human agent. Those kind of escalation mechanism or exception handling mechanisms should be built in within whenever you're deploying conversational AI. So it shouldn't be the end of road. So that's how most of the companies operate today. For example, initially when you start interacting, it will use conversational AI. If conversational AI is not able to answer that question, or if this problem is more complex for the conversational AI to understand, that's where it get transferred to a human agent. So those kind of like scenarios or workflows should be built in with conversational AI. So analytics and supervision. So this is very important. So what we do is we have also deployed, like especially in the UK, right? We have something called councils, which are responsible for managing a particular locality or area, right? So if they are like as a resident of a particular like locality, so you will go to the like what you will do is, like for example, if I'm having any difficulty in my locality, let us say the garbage was not cleaned properly, so what I'll do is, like, I'll make a call to council. So there we have deployed conversational AI. So what it'll do is, initially it'll go to that conversational AI, and then it will based on this interaction, even without involving any human, it's able to solve. So that is what it's called contact center. So we have deployed AWS contact center for different councils. So that's where conversation, we'll see that architecture also in a moment. But those are the scenarios. Once you completed your interaction, right, what it'll do is it'll automatically log all the conversations you're having, and then it will take it will do data analytics on that, and then it will provide a summary of what the user request was. So okay, the user came with a problem that the garbage was not cleared. So I went to the vendor. I checked the vendor who was responsible for cleaning the garbage for this particular day, and then I created a ticket or a task for them to take care of this. So this was the summary. So those kind of things, right? It can provide to a human supervision a supervisor. So those kind of scenarios also should be built in for the conversational AI. That's where analytics and supervision. And next is integration. As I told, it should be able to integrate in the same scenario, right? So if there is the council has appointed a third party to take care of on keeping the locality or clean, so it should have an interface to see what's responsible for cleaning up the streets for the day, and then like based on that, right, so that it can go and check those information, or it can create tasks in the third party system. So those kind of integrations also should be built in with conversational AI. So that's pretty much it. Yeah, so this is a detailed architecture. You can think this as of a HLD for conversational AI. So what are the different elements that will be there in the user interface? So, for example, it can be a customer user interface. It can be you can deploy conversational AI as a browser plugin or an instrumentation, or if it is a messaging platform, you should use your mobile phone and type the messages. Or, for example, let us say if you use voice, right? So just like in case of Siri or Google Assistant, right? So you can interact with voice. So the user interface usually deals with that. Or multimodal, it can be multimodal. It can accept inputs either in audio or text or speech, whatever it's, or video. So it should be multimodal. So those kind of things are handled in user interface. So whereas contextual awareness, right? For example, conversational history, this is an important part. For example, today I interacted with a, let us say, Swiggy, and tomorrow I'm coming back and interacting with, it should remember by whatever the previous interaction, how I interacted, what was my preferences, what was my tone, how satisfied I was. So those kind of things will be maintained in conversational history. And then also, like, let us say I'm asking 10 questions in a row. It should answer, like, it should know what was the first question, what was the second question, what was the third question. So what was the relationship between this all these questions and responses, and then based on this relationship and question, it should answer the fourth question. So for those kind of things, right, you will use conversational history. So your conversational AI should support that. So usually what we do is we will use this conversational history will persist into a database. For example, if you're having an interaction with conversational AI, that interaction would have been summarized and it will be stored in a database. And then later when you come back, right, for that, it will know this is the particular user and this was the interaction we had. Okay, so now if you're beginning a new conversation, right, it will check whether if it's related to your previous conversation. If it's, then it will use that. If not, it'll get the style of interaction from that previous interaction and do that. So that's where you will use conversational AI. And as I told, user context. So different users needed a different personalized experience, right? For example, if we are the people are older, right? So they might type slowly or speak slowly. So so that the conversational AI should be like capable to understand the slowness, or they might miss out certain words, so should be able to fill in those words. So needs to know that user context. So for example, if a native English speaker, they might speak very fast in English. So whereas non-native speaker might not speak very like fluently in English. So it needs to understand that user context, and based on that, it needs to respond. So that's where, and then user attribute predictions. For example, if you're interacting, what are my preferences or way of communication which I prefer. So those things, right? So like demographics I told. So whether they are an older person, whether they are or a native speaker, non-native speaker, those kind of attributes, right? It's able to, should be able to predict. So those kind of things are taken care in contextual awareness. And next is user preferences. For example, if I'm interacting with a chatbot, let us say in a Netflix, so I would prefer certain genre of movies in Netflix. So it should like whenever you're deploying conversation AI, it should respect that my preferences. So those are the things. And then second or third party user data. Okay, right? So if you're having second or third party user data, it should use that as well. So proactive conversation. So it will proactive address conversations. That's pretty much it. Okay, so next is behavior prediction. So it should also uh, how the user predicts behaviorally. So that's also it should take and respond. Um, So next is integration. So integration is, for example, it needs to integrate with different third party. It might be for differing intent. For example, there is a particular intent. Let us say the user wants to interact in, let us say instead of English, they wanted to interact with in Hindi or in Tamil. So in that case, what will happen is, so it should be able to like defer that particular to instead of uh, those kind of intents, right? Whatever models that are specialized in handling such intents, it should be able to transfer to that. So keyword or phrase matching. So this is also another integration. For example, there is a particular keyword, so it should be able to use that and then search third-party database with that. So those kind of or custom integration, like I told, the base management third-party platform. If you needed to integrate, those kind of will be custom integration. So those kind of scenarios, right? So it should do. Um, like those are the external factors. How will you do? And then these are the some of the things which I've already covered: intent handling, and then decision tree, knowledge search repository, which will use in order to uh, do behavior prediction, those things. And next thing, intent matching, right? For intent matching, these are the different things which you can do. For example, contextualization, intent grouping. For example, the age groups, right? Gen Z will be interacting in a particular way, whereas Gen Y will be interacting in a different way. Those kind of intent grouping should happen. And then multiple handler support. It should be able to support multiple handler. For example, let us say if I'm like if depending upon the native or non-native speaker I told, right? So based on that, it should route me to the different scenarios or understanding. So those kind of scenarios, those are called multiple handler support. Then multiple intent recognition. So depending upon the different age group intent, so it should be able to cater that. So those are the scenarios. And then terms extraction, pattern recognition. For example, if the customer is interacting in a certain pattern, it should be able to pick that up. So those are the things you will cover in intent matching. So next is natural language support. So in natural language support, it should provide language support. Like not only English, if it is a different language, it should be able to support, just like we mentioned in the Swiggy scenario. And then semantic sentiment analytics. Okay, for example, as the customer interacts, right, it should understand the sentiments of the customer and it should automatically align its responses. So, so for that, it should have sentiment analytics. So sentence rewriting. For example, as I told, whenever a aged person is interacting with a conversational AI, they might type something wrong or they might have missed out words. So the NLP will take care of those rewriting scenarios. So semantic enrichment, semantic is, for example, if I ask a question, it should be able to see which, like whatever the questions I ask, right? So it will it will be able to understand like how whatever response it needs to give, it needs to closely semantically match with that. So those kind of scenarios. So that's pretty much about how the architecture, and then as I told, exception handling. These are the different scenarios. For example, human fallback or human to bot handover or bot to human handover. Those kind of scenarios needs to happen, and then self-service routing. For example, let us say uh, there is already a knowledge article which customer itself can use to fix a particular problem. It should be able to give that self-service uh, routing, so then clarifying dialogues or modality switching, those kind of things. In analytic improvement, like so we have already covered this, as I told, like quality assurance. So it should monitor all the conversation and improve the analytics, those kind of scenarios. So next thing is we have covered the architecture so of conversational AI. Next thing, the important part, right? So conversational AI chatbot using RAG. RAG stands for Retrieval Augmented Generation. So why we need retrieval augmented generation? One thing is whenever the LLMs are trained, right, they will have a cutoff, knowledge cutoff date. For example, if you remember GPT-4 would have been a knowledge cutoff of in September 2023. So which means that it would have been trained all the information until September 2023. Whatever has happened after that September 2023, it will not know GPT-4. So what will happen if you ask any questions which is related to 2024, which related to the event that has happened in 2024 or 2025, it might not be able to answer. It might hallucinate. So uh, in order to avoid this scenarios, right, that's where you will use retrieval augmented generation. Okay, so in order to balance that outdated public knowledge, what you do is whatever the present scenarios, or you will have use a connector, a federated connector, which can connect to the current knowledge or current event which is specific to your use case, and then it can response to that. Okay, so for example, if you see, right, you ask a write a model class using latest version of Flask SQL Alchemy. So this is one of the question it answered. Like if you see, it responded, but it will responded this Flask.
केवल पर्दे क्यों उतारने गंदी नहीं ये नहीं है क्या गंदे हैं ड्राइंग रूम के
Yeah, so like yeah, this is one scenario, right? So it was using a Flask SQL Alchemy library which was outdated. So it's because it didn't know, like when it was trained, that large language model was trained, that was the latest version, but that has changed now. So those kind of scenarios, right? And also for example, in this case, right, so the user comes and asks, like, do my company perks cover underwater activities? So it says that to determine whether your company, you should consult and reach to your human resources. So there is no internal knowledge here. It doesn't know like whether your company covers any underwater activities perks as part of your employment or not. So in this scenario, right, so these are the scenarios the normal LLM or Gen AI model will not be able to handle, or a conversation AI might not be able to handle. So these are the scenarios where you'll use uh, like RAG, retrieval augmented generation. So with that, so now we saw what is the problem with the traditional LLM or Gen AI models or conversational AI chatbot that uses traditional LLM models. So next we'll see how to address this problem. So next thing is so first thing, how to address this problem is the first thing which you will do is prompt engineering, which is also called in context learning. So what you'll do is you will use prompt engineering in context learning. What you'll do is whenever you're sending for example, let us say I'm asking a question to a large language model. So what I'll do is like I need to provide a prompt, right, to large language model to answer my question. So what I'll do is like within that context window of my question. So with that question only, I will provide my proprietary data. For example, let us say I'm asking to about a event that has happened, who's the let us say GPT-4 was trained, knowledge cutoff date was September 2023. So then I'm asking about an event that has happened in 2024. What I'll do is like I'll provide that event details about that event that happened in Jan 2024 as a within the context window. Along with my question, so that I'll ask the LLM to answer the question based on the context it has been provided along with the question. So those kind of scenarios, right, you will do. So that's called prompt engineering. Also, this is called in context learning. Within context, you will, so in order to like compensate for outdated public knowledge, right, which the LLM is trained, you'll use in context learning. So that's one like how you can incorporate domain knowledge into the LLM. For example, if it is a you're using for the conversational AI for banking domain, so you can how the interactions should happen in a banking domain. Those things you can provide as an interaction, provide as a instructions within the context. So those kind of prompt engineering scenarios you can use. Next is fine tuning. So for example, if you want to fine tune, right? So this is like another scenario. For example, the layer, right? The LLM model, which is built on transformers. So I remember like earlier in previous session, we covered what is the transformer architecture is. There'll be a different kind of transformer architectures where they can be encoder, decoder, transformer architectures, right? So those kind of scenarios. So those kind of scenarios, right, it can handle in fine tuning. So what you will do is you will train the loss layer of the model. There can be different neural network layers. For example, if there are 20 layers, in that you will add another layer, which is a 21st layer, and then you will train your domain knowledge. For example, banking domain knowledge would have been trained on that 21st layer, so that that's what it's called fine tuning. But this one is very like one of the disadvantages. You needed a lot of computing power, especially for large language models, right? Um, so you needed GPU compute, even an hour or like let us say I needed an hour of GPU compute, that will be like in thousands. So as an individual, I'm not be this scenario of fine tuning will be suitable for large enterprises, or if you're a company which you're building this conversational AI for a large customer base, then it should be affordable. But in say other scenarios, this is very costly. Also, you needed a quite a bit of technical expertise in order to do this. So those are the things where how will you do fine tuning? Whereas prompt engineering, it's although this also requires skills, but this is usually doable, and then this is also less costly or more from cost perspective, it's more affordable point of view. So the fine tuning is that's what it. Next thing is retrieval augmentation. So like retrieval augmentation is what I'll do. It's like, for example, let us say I will the conversational AI has been deployed in a banking application. What I'll do is like I'll take all the conversational uh, interaction previously human customer and a human client had, and then I will use that to train the conversational AI model. And then also, for example, if there is any knowledge, internal knowledge bases, for example, let us say the new customer wants to know how to open an account with my bank, so I would have add like a certain knowledge basis which says the process to create a new bank account for a customer. So those knowledge bases will be ingested into vector database, and then so that vector database will be used. So whenever it needs to respond to the customer, right? Whenever customer asks a question about creating a new bank account, first it will go. It will see what is the customer as the question is about, and then like what was the relevant knowledge basis that has been stored in vector database. It will retrieve that first, and then based on that retrieval, it will augment its response. So that's what's called retrieval augmented generation. So it will temporarily learn new facts, and then based on that it will respond. So this is another scenario. So a quick example about retrieval augmented generation. A user comes and asks, like, I'll show the demo in a moment. So user asks, like, like what is included in my Northwind Health Plus plan that is not in standard. So that's the user question. What it will do is first it will go to the, so this Northwind Health Plus plan documents, right? So this is an insurance. This conversational AI has been deployed in a insurance domain. So it first goes and then it searches. So soon after a user asks this question, right? What will happen? It will convert this question into a vector representation. So that vector representation, like this vector representation will be searched. So already this is the vector database. This vector database will already stored all the details about this Northwind Health Plus plan. So what will happen is, so it will vectorize and store. It will match the vector a three-dimensional space. Vector is a three-dimensional space. It'll, okay, so user asked this question. This is the vector representation for this user's question, and then whatever is knowledge base, for all those knowledge base, like these are the vectors in the knowledge base. It will match both of the vectors. For example, the vectors in the user question and the vectors that is there already in the knowledge base. Then it will bring out all the vectors that matches with the user question vector, and then that will be provided. Okay, so this is the scenario. So this knowledge, for example, let us say it says the knowledge base says, right, both plans cover offer for coverage for medical services, and then this blah blah, and then that will be provided as a context to large language model, so that even though the large language model doesn't know answer directly to the question, it has been provided as a context to this large language model, which will use this information, this new information, to answer the user question. So finally it answers the user question. So, and then it tells that the conversational AI tells that both plans offer coverage for medical services such as doctor visit and lab tests, but Health Plus plan also covers hospital stays and X-ray. So this is called retrieval augmented generation. So like in conversational AI, so how that uses, like how that compensate the outdated knowledge or a domain knowledge of your conversational AI model. So this is the typical flow of a conversational AI chatbot. So soon after you ask a question, user ask a questions either through text or speech. So what it'll do is there'll be a AI. It will rewrite your query. For example, I told, right, so there can be different question. There can be spelling mistakes, or you could have missed a word when you're asking question. It will automatically rewrite. It will do all the sentence corrections, and then it will efficiently rewrite so that it can search the vector database efficiently, and then it will once it's rewritten, it will use that rewritten query, and it will do the internal search, which is your vector database, and then based on that it will generate the answer, and then after generating the answer it will evaluate whether the answer is like appropriate, or it is if it is uh, answering the user questions or not. There are different eval techniques, for example, context relevancy, or groundedness, how relevant uh, the answer is to the question user asks. So those kind of things will be evaluated. And then if it is a low score, right, what it will do is it will, like, if it will not display the answer. It will see what is the next thing it can do. For example, in order to further improve, right, it will either go to, it will again do the internal search with updated like internal search query, or it will go to the web. It would have it would have been provided with tools which will do web search over and above the internal knowledge, so that it can further answer, and finally it will generate the answer. This is one flow. Like if the score is high enough, yeah, it will. If here this is a decision making. If it is a low score, it goes what needs to do next. It either if it is not a low score, it either directs, like it displays the answers directly. If it is a low score, yeah, so it had evaluated the answer. It had the answer score was low. It'll go and reflect like whether that answer was appropriate or not. Based on that, it takes action and finally does all this and displays this answer. Like so the next action in this case, right, if it is not a low score, it directly displays no action is required. If not, it will further like see how to evaluate and use different tools at the disposal of conversational AI to further improve. And after generating, then it finally displays this answer. So that's the flow of a like a conversational chatbot using RAG, how it will self-evaluate, reflect itself, and further. This is how it will. In a whenever you would have observed, the first interaction you're doing with a banking chatbot would be different when you're doing the second or third or fourth time, because it would follow this process of reflection and self-evaluation, and it will based on your previous conversational. As you interact with the chatbot, right, it will continuously learn and it will evolve and it will improve its answer. So that's how these are the particulars, like what's happening in the background of a conversational AI. So with that, we are getting into the live demo, the exciting part. So we are almost to the end of the session. So now let's go to the live demo. So what I'll do is like I'm going to demonstrate to you a RAG chatbot. So just like which I showed here, which is trained on the insurance Northwind Health Plus plan knowledge base. So I'm going to demonstrate that. We'll demonstrate natural language understanding capabilities. Like we will highlight the response generation and user engagement, and then we will illustrate integration, how it's using retrieval augmented generation, and then we will emphasize practical application in customer support and virtual assistance. So that's pretty much with that. Let me take you to the RAG demo. So earlier I told about earlier I told about like conversational AI, right? So how the vector search happens. Before getting into the demo, I wanted to quickly show you that. So how the vector search happens in the, I told that user asks a question, and then what will happen is it will, let us say I'm searching for a word. Okay, so let us say I am searching for a word, um, capital. Right. So if I search for the word capital, right? So what it will do is soon after I search, what will happen is this will get converted into a vector. So and then it will go to the vector and then it will search, right? So it will say it will give me a score. Like this would have been converted into like a vector representation. This vector representation, right? It will tell me what are the words that are closest to the word which I've asked. This is how it happens in the retrieval augment. User asks a question. This, let us say user asks, what is the like how do I open a banking account? So that banking account will be converted to vector, and then that vector, let us say that for example the word new account. Okay, so new account, let us search new account, example account. Right, so if I search about the word account, right, so it will say like what are the different words that are matching with the account word it displays. So it can be in any of the domains, right? So it'll closely, this vector search will match, semantically match this word with that particular word that is already in the database and bring up all the all the knowledge documents or words that are closest to this. For example, if I ask about catch, right, capital, if I tell about capital, the highest, in vector space, the highest word that is closest to capital is city. So you can see that's why in the vector dimension space, the word city, right, would be closer to this. So if you see here, like this is capital, this is city. So if you see, so it is closer. It is in the capital and city are much related to each other. So that's why it is related. For example, let us say the village, right? So if you see village, right? So distance between village and the capital is very far. It's because like usually village might not have a capital, right? So that's the reason the the vector score is a bit lower for this village, which is in terms of when compared to capital. So that's how the how vector search works, how it compares, how it converts your each of the words that user ask into a vector representation, and then it compares the nearest thing, and it brings out all the things that are closer to your word. So that's pretty much it on how the vector database will happen. With that, we'll get to the question. Okay, so you can see this is how the capital in vector representation. This is capital. What are the words surrounding the capital as being closest? If it is investment, capital and investment are closest. So you would see that's why it's very nearer. Like, yeah, so investment is related to all other related words, which is investment in banking, monetary investment, or debt investment, or taxes, or financial. So that's how it happens. So with that, let's go to the demo. Okay, so as I told, so this is a demo, like this is a conversational AI application that has been asked. So there are two things. You can do a chat style question where you will chat it, like just like you see a message. So next thing is you can ask a question. So for example, if you wanted a question, so you can ask a question answer style. So whatever it's preferred. If you do chat, this is where it remembers the question. If I ask 10 questions, right? It'll remember all the, like whatever answer it gave for the 9 questions. Based on that context, it can answer the 10 question. I'll tell like what is included in my Northwind health plans that is not in standard. So like it generates the answer. So these are the, like as I told, this is an insurance chatbot. So it tells that these are the like things that has been covered. So this chatbot, as I told, this chatbot has been deployed for insurance domain. So it has been trained on we have provided these not this documents as a uh, we have provided these documents as a we have already ingested these PDF documents which tells about this Northwind Health plan benefits into the vector search. So what it does soon after I ask this question, so it will convert this into a vector space. It will go to the vector database. and then it will search all these documents, all the documents that has been ingested into vector database, and it will bring up only document that matches vector in vector space that are closely matching with this question. It will bring up all those documents and it's displaying here. Based on that context, the conversational AI has given me the response saying that these are the services that has been covered in this insurance plan. So if I want another thing, right? So citations, from where it took this information from. For example, all this answer was provided based on like let us say this is a citation. In a moment, it will load the actual PDF that was uploaded or ingested. Like this was the insurance plan. In this insurance plan, you can see that on page 3, like it used the information from page 3 to answer the question. So which you can see. By this way, we can readily verify where that particular. So this is very much useful, right? For example, like how uh, some at certain times you might think, okay, how the LLM generated this answer, from where it took the context. So those kind of scenarios, right? This kind of scenario provides confidence to users. It improves client interactions to tell where it actually took this information from, so that it can so you can know, okay, so this is the insurance plan, this information came from this page, and then based on this it gave me the answer. So I can trace back the source data source based on which the answer was given. So so for that scenarios, these citations are very useful. So you can see the supporting content, especially these are the chunks that has been retrieved from the vector database. For example, I've what I would have done, I would have done is initially for the first, in terms of data preparation, I would have taken this PDF, converted to text, and then I would have chunked this text into different parts, smaller parts, and then I would have ingested into AI search. So when I asked this question, right, it went and it brought this chunk which is related to this question, and then based on that, so it tells that, okay, these are the chunks that are being provided as a context. Out of these chunks, I have used this one, like page 3. You can see here, right? So there are lots of chunks. So like there is page 3, there is page 48, there is page 75, but it has used only the 3 pages. It's because all other pages are not relevant to this question that user asked, so it has safely neglected that. So that's thing, the thought process. For example, how it happened. Usually user went and asked the question. So this was the role of the user. You can see my question here. And then it uses retrieval technique. It went to the knowledge base. It brought up all the top 10 chunks, the document chunks which are related to this question. And then, so it did query rewrite. Like you can see it has created a query, and then based on that, it bring all the context, and then finally using the prompt, it generated the answer. So it had used like so it used GPT-5 model. So the reasoning efforts were minimal. So if you want to increase the reasoning effort, so there is a developer setting. So you can go and increase the reasoning effort, or you can even, so the GPT-4 model, it's a new type of model that has been released. So which like you can select the reasoning, which supports reasoning effort. So it has a router in front. What will happen is, so you ask a question. If the reasoning effort is minimal, it will go to one model. If your reasoning effort is high, right? So it will go to another model. So those kind of scenarios, for example, these are like technical things which you can fine tune to improve your answer. For example, if you want to like have more reproducibility, you can give the seed value, and then if you don't want like if your conversational AI need to be more creative. For example, let us say you're writing scripts for a movie. So in that case, you will have high temperature because the model can turn into more creative, and it can, for example, if you're giving certain movie scripts, right, it can further make it more creative, or it can fine tune it. In those scenarios, you will do it. You will increase the temperature, like, whereas you don't want it to be very creative. It needs to be like reliable, and then so it generates an answer. It should be more grounded to whatever the domain specific. For example, if you have deployed this application in a banking scenario, or in this case, it's an insurance domain. That's why we have set the temperature so that it doesn't hallucinate, or doesn't become more creative and hallucinates. It just answers from the question. So like if you wanted to overwrite, we have already, as you saw in the thought process, we gave a prompt. So we have already a pre-built prompt that has been given. So it uses that. If you wanted to override, you can do that. So these are the other settings in order to improve your search query. So if you click on this, right, so it will also suggest your follow-up question. For example, I will check this. So let me ask the question again. Does the plan cover my annual eye examinations? So this will answer the question, and also it will suggest me what next question I can ask. Uh, so you can do that as well. So generating the answer. Yeah, there is a problem with this GPT-5 model where the routers are, it's a very new model. It was released, I think, this month, so in August. So sometimes it's a bit slower with higher reasoning. So if you set it to higher, that's why it takes time to respond. If you set it to lower, it must be quicker. So I think the OpenAI are fixing that. So that's one point. So if you're setting your reasoning effort to high, you should be aware like it may take more efforts. So for time thing, so I will like set it to low for time being and close the session. I'll ask the question again so that it uses. Uh, Let me refresh this. Yeah. So finally it has come back. So yeah, so you can see here, right? So it asks like, yes, this plan covers eye examinations, and then so which page, so from which page it retrieved this answer, it has said that. And then you can see what are the follow-up question I can ask. It already suggests. So if I'm lazy to type it, it gives some suggestions, so I can use that as well. So or glasses or contact lens covered too. So I asked that. So this time it should be faster because the reasoning level has been set to low. So yeah, it's faster. So like based on the scenarios, right? If it's very complex scenarios, so then you can set the reasoning level to high. But for simple scenarios like this, you don't need. Yes, it covers classes. So I'll stop here and open up for Q&A. So that's the demo about conversational AI.
Yes. Any questions from the participants? If you have any questions, you can raise. Yes, please. Now the session is open for question. You can raise your questions to Bharat sir.
Okay, so I think hope you understand. So if you have any questions, you can reach out to me on LinkedIn. So I'll share with Madam on LinkedIn, so you can connect and reach out to you, to me. So yeah, we can answer that. So with that, I'll stop here and hand it over to the
Yes.
Madam.
Okay. Thank you so much, Bharat sir, for your comprehensive talk on conversational AI and chatbots, covering both the theoretical aspects as well as the real world applications of the technology. He nicely began by breaking down the concepts of conversational AI, clarifying the distinction between conversational AI and generative AI. And the speaker also effectively used real world examples such as virtual assistants like the banking chatbots, namely EVA, and AI powered customer service agents to make the content relatable and engaging for the audience. The major highlight of Bharat's talk was the exploration of RAG, the retrieval augmented generation approach, where he explained how conversational AI can be enhanced by integrating the external knowledge bases and live data sources. He also covered how these AI systems can adapt and improve over time by fine tuning their responses based on user feedback, providing a dynamic and evolving experiences. He also elaborated on technical challenges such as outdated knowledge in LLMs and introduced a prompt engineering and how to write effective prompts and how to make the ChatGPT to a like which means the conversational AI to give us exact answers and how the approaches, namely conversational AI and Gen AI, work together to offer more adaptive and personalized engagement, also been taught. And throughout the session, he maintained a clear and approachable delivery, answering queries like actually the we how to raise questions and how the queries are answered. So like that, he has given exact prompts and he also tested and. Your presentation was really informative and engaging, sir. Thank you so much. Hope you to
Thank you.
join us in the valedictory session by 7:30 p.m., sir.
Sure, ma'am. Thank you.
Thank you. I will
Yeah.
be sharing you the separate link for valedictory.
Yeah,
Yes,
Thanks for
sir.
sure,
your
ma'am.
I will
presence.
share with you. And there was
Okay.
one query from one of our audience. Hello, sir. I want your insights on perplexity versus Gemini.
Yeah, so Gemini is a Google model, so which is an LLM. So it's the latest model. So let me quickly share and show you. So just like how GPT-5 and like GPT-4o or ChatGPT, just like that, Gemini is one of the large language model. So yeah, so whereas the perplexity, what they're doing is so they are augmenting, just like I showed, right? So we use retrieval augmented generation. What they do is they take the base model. So there are lots of open source model like Anthropic and the Cloud. So those kind of models, they take it and then they train it. So Gemini is a closed model, so they don't reveal their architecture or weights of the model that has been used to train that deep learning model, because that's the business, right? So so whereas Perplexity, what they do is they take out the open source model like Anthropic. They like that is Perplexity. They take out Anthropic Cloud, those models, or Llama, Meta AI models, right? So those are, what they do is they publish their weights, like how they train the model, what are the weights they use to train the model in the deep learning network. They take that and then they publish that so that anyone can take that weight, they can train that on their own, and then they can use that. So that's the basic difference. Perplexity does that and expose it as another model to you, so that you can use that open source model, or instead of using a pre-trained model like Gemini, it can use the open source model. So that's the basic difference. So in terms of Gemini, you can think of it as a closed model, whereas Perplexity, it majorly works on open source model like Cloud. So where they publish the open weight model, it provides the opportunity to fine tune and like further train on your domain knowledge. So that's the only thing. So that's the key difference between Perplexity and Gemini.
Fine, Bharat, sir.
Any other doubts?
Why may say accuracy is better? We may say
We may
accuracy is
say,
better.
yes. How we say,
Yeah,
right? I think.
How can we say accuracy is
Uh,
better?
so that's why,
Um,
as I covered in the session, right, we
Hello,
need to
sir.
do,
Am I
yeah,
audible?
yeah, you're
Yeah.
audible.
So, my question was like comparing Perplexity and Gemini.
Sure.
I personally use Perplexity because I find it more reliable.
Okay,
is compared to Gemini and ChatGPT is what my say was.
sure.
And on accuracy purposes, like on based on accuracy, which do you think, like Perplexity or Gemini, like which do you think has a better accuracy towards any approach, any algorithmic approach?
So I would say first it will depend upon the domain where you're using the model. So yeah, Perplexity you might have worked in this, for example, normal conversational, right? It would have worked very well because they would have primed the prompt engineering. They would have used some of the prompt engineering. As I told, Perplexity takes the open source model and then they fine tune them using prompt engineering technique, which we discussed. So that's why it's better. But in case of Gemini, right, that's a raw LLM model. So it was not fine-tuned on prompt. It works on your like whatever the prompts you give. So what you can do is you can fine-tune the prompt of Gemini, and then once you do that, right, obviously the accuracy of Gemini also will be higher when compared to Perplexity. So that's the scenario. So there is no straight answer for this because it depends upon the domain where you're deploying this conversational AI or Gen AI model. That's the question. For example, let us say you're deploying Perplexity on a banking domain, right? You need to fine tune the Perplexity models to work. You need to fine tune or use retrieval augmented generation techniques to give appropriate or accurate answer in banking domain. Whereas Gemini, the same goes for Gemini as well. For normal chats, right? So for example, you can fine tune the prompts. So the system prompts and user prompts. System prompts are nothing but the instructions which you give to Gemini. For example, if you see a disadvantage, whereas I ask a question and it has not responded to that scenario, it might be because it doesn't have the data or accurate data on which, or it might have trained. For example, Perplexity used Cloud that would have trained on the knowledge cutoff date for Cloud might be uh, a Jan 2025, whereas for Gemini model, it would have been Jan 2024. There is a 1 year gap, right? So you needed to see those are the things. So what is the knowledge cutoff date, whether Gemini was trained on the latest knowledge or not. So if it is not trained, what way, how can I give some extra knowledge in the context so that Gemini can handle appropriately? Those are the things which we need to evaluate. So that's the reason why we have evaluation. So whatever scenario you deploy a conversational AI, you need to always like measure its responses, evaluate its responses, and accordingly take an action. So there is no one short answer. So if you tell me where you're going to deploy Perplexity or Gemini, maybe I can tell you how you can improve accuracy of both, what techniques you can uh, deploy to improve the accuracy. So that's the
Uh,
explanation.
Sir, I would like to interrupt. The thing is, like, Perplexity became very famous, like, recently. Like, it came into existence. So it was because that, like, Perplexity uses a lot of different models. Even it uses Gemini 2.5 Pro model as well in order to generate answers. But
Sure.
as far as I know, like Gemini doesn't have that option wherein you can choose your models, because Sonar is a in-house built model which Perplexity has created, right? So it's a pro, right? Like when we compare two different AIs, open AIs, so we can say like generative AI for Perplexity is better. We can because we can choose various models to work with, whereas Gemini is
Yeah,
like based on one particular thing.
but GPT-5 is doing that already. They have a router. They are based on the reasoning, just like as I showed in the demo. It can route to different model based on the it assess your user question, and based on that it can route. That's one thing. Yeah, I agree there. The Perplexity, it's fine-tuned and it uses different models. That's what it's changing in agentic, right? These days, agentic is like even Google has done a lot of things in agent space. So they published an agent SDK, so Google Agent SDK, which can, like, what it can do is it can use, instead of using one LLM call, it'll use multiple LLM call. It can like reflect on its answer. It can further improve it. So this scenario, right? So if you go for accuracy, like if you can use uh, Gemini as a will be way higher than Perplexity as well. So that's my take. But yeah, so I agree there because you can't compare Gemini and Perplexity. It's because Perplexity works differently. It uses multiple models, just like an agentic AI. It uses multiple API calls. So whereas Gemini does all this in one single LLM call, so that is the thing. If you wanted to use same way, you wanted to experience same way as Gemini, right? So as Perplexity in Gemini, instead of using Gemini directly, go to agent space. So agent space is again, you don't need to know, it's a no code solution where you can go and interact, use agents to interact. So you'll get optimal responses there, even better than Perplexity, I think. So agent space is a new thing that is coming up with the GCP. Google Cloud is coming up with. So if you are a hard coder, then you can use ADK, Agent Development Kit in Google Cloud, which will like push your accuracy core a lot better than Perplexity itself. That's one thing. So the next thing is, yeah. So if you for the similar scenarios, right, where you wanted to deploy customer service, so you needed to deploy Perplexity and you need to measure both how it performs and choose the appropriate model there, whatever gives you a higher accuracy. But there are ways to improve the accuracy. So these are the things which I would recommend, different things
Yeah.
which you can try.
Bharat sir,
Thank
I
you.
have one doubt.
Sure.
If suppose we are creating a chatbot for our educational purpose, which tool you will prefer? Which Gen AI tool?
So I would go for agentic approach. So like
Again,
because
we have to use some Gen AI tool for agents, right? As an agent.
yes, ma'am. So
Uh,
as I told, there is lots of like you are a academic person, you don't want to code or something, then I would suggest go for agent space. So like what you can do is you can create agents there from the UI itself and use that. So instead of using single LLM call, you can use multiple, that will use agents will use multiple LLM call to fine tune itself. It will be autonomous, it will fine tune you itself, it will correct itself before giving you answer. By that way you will get an optimal responses and answer. So that's the
okay.
approach as an industry today, right? We are moving towards agentic. Yeah, we tried like single LLM calls, single
So
models
if in
that was.
case we are creating for our university, a chatbot for our university, so then if anything, like if suppose it is checking for multiple calls, will it be correct? How we will be creating the ground truth text?
Okay,
So
so
what is the possibility?
the first process is, let us say, it depends upon the purpose for which I create the chatbot with. Let us say VAT want to create a chatbot
Yes.
that
Mm.
supports students in their application onboarding or joining the college. So what I'll do is
So
like I'll
if it is supposed to clarify their doubts regarding the academic purposes,
okay,
like
okay.
academic related doubts.
Okay. So the
Okay.
first
Mm.
thing which I will do is like there should be a knowledge base for all the academic documents or PDF documents. So if it is a knowledge base, I'll create a search tool with integrate with that knowledge base. So whenever user asks the question, so what it'll do is it will go to that, it
Knowledge
will,
base.
yeah, knowledge base. It will find what
So
is the
what
relevant.
might be the size of that knowledge? Is there anything like we should have these many scripts in that knowledge base or the relevant? So is there any size required for that?
No, there is no size required. So there are different things that knowledge base should be designed. For example, if it is what are the different document types in knowledge base? If it's all or pure PDF, then what you can do is you can vectorize and ingest into a vector database. So vector database is a high dimensional database. It built for massive amount of data. It doesn't depend upon, it can support thousands or millions of PDF pages. So it's built for that. Cosmos DB supports vector database. So you needed to ingest all those knowledge base into vector database, and then use that vector database to ground your chatbot responses. By that way, it'll use that. It'll go and check the knowledge base. It'll search the knowledge base. It'll retrieve whatever the question that is asked. It'll retrieve all the documents, just like I demonstrated. It will retrieve all the documents and it will answer the question. That's the way we should approach. So once we do it with agent, what is the advantages? So it will first go, it will retrieve the knowledge, and it will automatically itself will evaluate its answer. It will reflect whether the answer is correct or not, whether something is missing. If it is something is missing, what it was missing, and then it will fine tune its responses before giving final answer, just like I showed in the flow. If not, that's the reason one of the recommendation to go for agentic approach rather than a single LLM call.
Yes, thank you.
So they've asked few questions. So the performance of LLM models, evaluation metrics. So yeah, so different evaluation metrics are there for LLM models. So one is groundedness, and other one is contextual relevancy. So how far your LLM response is grounded to your context. So that's one thing. Next thing is hallucination detection. So those kind of things, right? Those are the different like evaluation metrics you can search for. Let me quickly share my screen and show you the different uh, like evaluation metrics we are using. So give me a minute. Yeah, like these are the things you can use. So I hope you can see these are the like different metrics which you can use to track the LLM responses. It can be like LLM RAG. If it's a summarization, you will use LLM as judge. That's a formula metric to, you will use another LLM to evaluate the response of one LLM. That is called LLM as judge. So you can use that. Next thing is recall and precision. These are the advanced metrics. For example, if you're using entity extraction, you'll use this metrics. If it is a Q&A, so as I told, whether the answer is contextually relevant or not, whether it's grounded to your domain knowledge or not, those kind of the scenarios you will use. And next is conversational response or completeness. For example, if whatever the conversation, whether the response it provided, whether it complete or not, then those things you can measure. You can measure hallucination detection, and then if you are using agentic approach, right, whether the agent was able to complete the task appropriately or not, or else whether it was able to understand the intent of the user. Those things you will use, whether to use the tool correct. For example, in this scenario, right, madam asked about creating a chatbot for VIT, where it needs to retrieve the knowledge bases from a knowledge base, retrieve the context from the knowledge base. So whether it has used, what we'll do is we'll create a tool for accessing the knowledge base, and then whether the agent was effectively used that tool correctly or not, he will use that. Or else yeah, so bias and toxicity, there were some questions, right? So what is the safety of the LLM? These are the things like which will detect. For example, if they're asking some question, which, for example, I wanted to make a like a I wanted to do some violent activity. So what is the process for that? Your conversational AI should not be answering that, right? So there will be safety filters already inbuilt in your LLM. You can use that safety filters so that your LLM doesn't answer those questions. It safely neglects that. So that's what it this metrics, but those will come under responsible AI, where like bias and toxicity will be tracked, and then it will use. So there are lots of models that does it. Like one framework is deep eval, so which will use to, it tracks all these metrics. So you can refer this library, so which will tell you how to measure all these metrics which are for LLM in order to evaluate your LLM. So yeah, so once, and then it can publish this in a dashboard. So something like this. So if you go to um, uh, the deep eval platform, so it'll bring up a dashboard, something which you're going to see like this. Okay, so which will tell you like what was the LLM response, whether it was healthy or not, which system prompt version it used, and then those kind of metrics you can track in terms of LLM monitoring. That's to answer the question on safety and evaluation techniques. One library, open source library, which you can use is DeepEval, but there are lots of other eval, like the other libraries, open source libraries, to do evaluation. So if you're doing in cloud vendor, like Microsoft and Google have their own evaluation framework. So for example, Azure evaluation SDK. So AI evaluation SDK is there in yeah, this is the SDK for Microsoft. If you're using Azure open source model, you can use this to evaluate your model. There are different metrics you can evaluate. So these are the metrics you can evaluate. Okay. So yeah, I would, in order to understand more, like how to run the evaluations from Portal itself, Azure Portal, so you can explore this documents. I'll share this with the PPT so that you can explore this.
Yeah, thank you so much, Bharat sir, for your valuable time. We meet at the valedictory time. Thank you.
Yeah, thank you very much, Bharat sir, for your explanation regarding this LLM. We are also very much happy with the too much of information regarding this LLM models and how it was working with the chatbots. And participants, the feedback link is given in your chat box as well as it's given in your WhatsApp. Now we will wind up this session, and we will join in the next link which was given to you for your online test. Hopefully you will turn on your cameras for your online test, where madam will share you the link for your online test. Okay, madam, you can stop recording.